Hello, my name is Eduardo Insunza. I'm Business Development RF Test for VIAVI Solutions, and today we're going to be discussing the CellAdvisor 5G. CellAdvisor 5G is the industry's most advanced cell site test solution, ideal for validating all aspects of 5G cell sites. It covers three main aspects. One is 5G signal analysis, important to analyze bandwidths up to 100 MHz, as well as ability to analyze TDD signals, and that's specifically important for interference. And lastly, it also covers all aspects of the front haul, covering coax and fibre testing. It has a touchscreen cover. It has touchscreen stylus to interface with the touchscreen display. It has a kickstand on the back. It has removable handles on the side. The battery compartment, where pluggable, hot swappable batteries can be installed. And then on the top panel, where we have all the connectivity for the instrument, triggering, SFP for RF recipe, GPS timing, and RF port. And then user management ports on the side of the unit, where you have micro SD for storage, connectivity, local or remote with Ethernet, client USB, and power. Internally, it contains Wi-Fi and Bluetooth connectivity. Measurement applications. We're going to be turning on the instrument with a power button, and it's going to be running its self-test as well as initializing the individual applications of the unit. The whole initialization process is going to take between 1 minute. Now the unit has fully initialized, we can conduct some testing. We're going to be starting with 5G testing. In 5G, there are two frequency ranges, frequency range 1 and frequency range 2. For each one of them, we have two different sets of antennas based upon the test that needs to be done. In frequency range 1, we have omni antennas to conduct drive tests, as well as directional antennas to conduct specific interference tests. And then for frequency range 2, which is millimeter wave, we have omnidirectional antennas for drive testing, as well as horn antennas for interference finding. For 5G, it is important to analyze and look into the signal in real time. CellAdvisor 5G is equipped with a real-time persistent spectrum. Here we select the main menu. It's going to give us all the test modes, and in each of those test modes we have the specific measurements of that mode. We're just going to go and select, in this case, real-time spectrum. Real-time spectrum actually has a capability of analyze 100 MHz, which is really important for 5G signals. Not only to properly characterize the channel, but also to have the profile of the beams in 5G. In addition to that, it's also important to have a representation of possible interferers that with conventional spectrum analyzers will be difficult to visualize. In order to conduct 5G test signals, first, going back into the test modes, we're going to select 5G NR signal analysis, and we're going to start with a carrier scanner. The carrier scanner has the ability to test all the multiple carriers or channels that a single radio is transmitting. The main purpose of it is to verify that the radio is transmitting all of them at the same power level. CellAdvisor 5G here is going to show us 8 carriers, in each one of them a couple of indicators, one for channel and the other one for the strongest beam. Now that we have verified the radio is properly transmitting all those carriers, we need to validate beamforming. For beamforming, we need to select 5G NR signal analysis, and then we're going to select beam analysis. Beam analyzer basically is going to be showing us the 8 strongest beams transmitted off that carrier. This is going to give us a good indication of which radio is transmitting that beam, or PCI, as well as the power level and the conditions of the signal. Now that we have validated the radio is transmitting all carriers and beams, we also can select 5G NR beam availability, and that's going to give us a different perspective of the beams. In essence, it's going to give us an indication of all the possible beams available, which beams are enabled, or which beams are transmitted out of the radio. For example, in the case of FR1, possible beams can be 4 or 8. In case of FR2, which is millimeter wave, the radius can transmit up to 64 beams. Beam availability is not only going to give us an indication of which beams are enabled, but also the quality of the beam being received at this location. And finally, for coverage, the same test mode of 5G and RCN analysis, we can do route map. In route map, we just load the map of the area where we want to conduct the test. It's going to correlate the geolocation of the map with GPS of where we're standing. We just select play button, then it's going to start conducting tests. At the end of the test, we just stop the measurement and save it. It is recommended to select the result as CSV. That's going to give us all the data being collected in a CSV format for post-processing, as well as result, so later on we can analyze the same signal with the CellAdvisor 5G. For interference analysis, it's important to also kind of characterize the signal on real-time spectrum, not only with the real-time spectrum, but also with real-time spectrogram. In real-time spectrogram, we have the real-time spectrum, but as well we have a 3D waterfall that will give us a good visualization of possible intermittent interferences. In addition, that is important for TVV signals is to configure the instrument to analyze only for those time slots where the uplink is transmitted. That, inside of a spectrum analyzer, we have the ability to do a gated sweep. Here in gated sweep, we have in time domain the time of one 5G frame, where basically we can put a delay or a specific area where the spectrum analyzer is going to be conducting tests. Very useful for any type of TVV signal analysis interference. For 4G analysis or LTE, we select the specific test format, which is going to be TVV or FDD. And typically, to have a full characterization of the LTE signal, we do a control channel test. The CellAdvisor 5G is capturing the entire LTE signal and doing a full demodulation analysis of all the control signals. Just by selecting a different signal type is going to give us a good indicator. In this example, it's one of the MIMO signals is the reference signal 1 or antenna 1, with constellation diagram that is going to give us a good sense of the signal quality in this specific location. Similarly, to do a coverage test, we conduct over-the-air route map. We load the area of interest that we want to test, load it into the CellAdvisor 5G. That's going to give us a good correlation between the geoposition of the map and the GPS or the location of the instrument. Then we can just select the play button, and that's going to start conducting different tests. At the end of the drive test, we stop the measurement and save the results. The other important test for LTE is to conduct over-the-air measurements on the channels. And this is going to give us a good indicator about possible imbalances between MIMO signals. It's basically tracking. This is a histogram of the pilot signals from MIMO 1 antenna and MIMO 2 antenna. The purpose or the goal is to have both antennas at the same power level. If there's a gaps between them, there we have a power imbalance. The other important test to be conducted in LTE is an ID scanner. This is going to give us a good indication of how many radios are transmitting in this specific location. In this example, we're seeing that we have signals from multiple radios at the same time. This is useful to analyze or check pilot dominance, and this is for network optimization. Now we're going to be talking about front haul. In front haul, we have two main scenarios. One is with coaxial cables. Those are the cables from the remote radio head to the antennas, as well for the fiber cables that go from the radio back to the baseband unit. CellAdvisor 5G is equipped with a couple of modules, one for each purpose: cable and antenna analysis, cable and antenna module, and OTDRs for fiber characterization. In fiber, it's also needed to conduct fiber inspection with using a microscope. As soon as the microscope is connected into the USB port, it's going to have interface with it, and it's going to create a tab or a function that is going to be interfacing with the microscope. Here, when we can easily conduct fiber inspection tests, analyzing the cleanness of the connector. Once that's completed, then for fiber, it's important to do a fiber visualization, and we have a fiber optic interface by connecting the fiber into the OTDR. And here we have the trace of my fiber link. For cable and antenna testing, similarly, we have an icon for a cable and antenna analyzer. We select the frequency of interest, and once that's completed, we just need now to calibrate the CellAdvisor cable and antenna module. To calibrate the cable and antenna module, we're just going to be using, in this case, an electronic calibrator. Now connected into my end connector, I just select the cal button. Automatically the instrument, it's going to recognize the electronic calibrator, and we just run the calibration. Automatically it's going to go into the sequence of open, short, and load. And now my instrument is fully calibrated. So now I can remove the electronic calibrator and conduct all my reflection tests. In 5G deployments, there are different topologies. One of the topologies that is mostly being adopted nowadays is with DWDM. And to have a full characterization in DWDM signals, in addition to conducting OTDR tests, with dense wavelength division multiplexing, we need to characterize each of the channels. And that's going to be conducted with a similar module that is channel checker. That's going to give us a full visibility of all different wavelengths transmitted on that fiber. For additional information about how to conduct tests with our test modules, please refer to the specific videos. For workflow automation, we have three main solutions. The first one is StrataSync. It's VIAVI's cloud service that is going to allow the instrument to collect configurations as well as save results. The Job Manager, which allows us to automate specific tests based upon the radio type or the cable type, as well as Smart Access Anywhere, which is going to allow remote access into the unit from an expert.
Find out more at Vicom's website.